Okay, we are in section 2.2 and we're talking about linear equations. And this is the form of a linear equation. We've already talked about linear functions. Now, what is the difference between a function and an equation? So an equation makes a statement, okay? So this particular equation says that ax plus b equals 0. That's a statement. And there are only certain values for which, and in fact, one value for which x will make the statement true, okay? Now, here you recognize this as a linear, an equation for a linear function. What this does is it relates x and y so that it describes a set of ordered pairs. Remember, a function is just a collection of ordered pairs, x, y. And so it describes that set of functions. Every ordered pair x, y that when you plug it in makes it true is part of that set of ordered pairs that describe the function. Okay, this is a linear equation. It has one variable x, and there's only one value of x that's going to make that statement true, and that's going to be negative b divided by a. So if you were to solve for x, you could see I could subtract b from both sides, and I would get ax equals negative b, and x equals negative b over a. Okay, so whatever b and a are, that one value, negative b divided by a, is the solution to that equation. In other words, it is the value that makes it a true statement. Here, there are infinitely many ordered pairs that satisfy this equation. So this describes a function because we're talking about ordered pairs, whereas here, we're just talking about one number, negative b over a. Okay, so how do you know if an equation is linear? What you want to do is you want to get it in this form, ax plus b equals 0. So here I have an equation, and I want to group all of the like terms together. So first, I'm going to deal with the parentheses. I don't want parentheses in my equation. So I'm going to distribute the negative to get rid of the parentheses, and I'm going to give negative 3x equals negative x. That negative is applied to the x, but it's also applied to the 2. That's the distributive law. Okay, now I want this negative x to be on the other side of the equation, so I'm going to add x to both sides. And I get negative 2x. This, of course, is 0. Negative x plus x is 0 equals negative 2. And I am trying to get it to look like this, so I'm going to bring the negative 2 to the other side of the equation by adding 2 to both sides. And you're saying, wait a minute, I thought you'd want to divide by negative 2. That's true if you're solving it. But remember, we're just trying to identify, is this a linear equation? Okay, so I have negative 2x plus 2 equals 0. So I have it in the form. Notice that my a, so this is ax plus b equals 0. So this is my a is negative 2. I've got my x, and b is 2. So since I've written it like this, I think I went a little bit too low I'm off the screen there. Sorry about that. I wasn't paying attention. But anyway, this value is a, and this value is b, and I've written it as ax plus b equals 0. So this is, in fact, shows that it's a linear equation. Now, let's look here at this one. All right, same thing. We want to go ahead and distribute these constants. So negative 4 times 5 gives me negative 20x, and negative 4 times negative 1 is plus 4. Then we have 8, and then we distribute the negative to the negative x and negative 2. And now we're going to go ahead and add x to both sides, so I can get this over here. And that's going to give me negative 19x plus 4 equals 8 minus 2, which is 6. And then I'll go ahead and subtract 6 from both sides. I get negative 19x minus 2 equals 0. So you can see I've expressed it in the form ax plus b equals 0, where a is negative 19 and b is negative 2. All right, so both of these equations are linear because I was able to put them in that form. All right. I might be running out of time. I have to keep my videos under a certain time, so I'm gonna log off here.